Finish out this week's module talking about normal probability plots. And we've talked before about the fact that if we're going to use a normal model, we need to know that it's unimodal and symmetric. And we've talked about how to create a histogram on our calculators or in StatCrunch or wherever else to ensure that it actually is unimodal and symmetric. But sometimes it's kind of hard when they make those histograms to see, is it truly normal? Like, how normal is normal? How do I know? So one really good way to check to see if something would fit the normal model is by making a normal probability plot, which is so super easy. So essentially what it does is it plots each value against the z-score that would be expected had the distribution been perfectly normal. So if it was exactly a normal curve, basically it's plotting those things against each other. So looking at this, this is a normal probability plot, and notice next to it I've shown you the histogram that it came from. So looking at this histogram, I would say, yeah, that looks like a normal model. Looking at the probability plot, again, what I'm looking for here is, am I looking at a straight line? And in this case, yes, I am. And so the straight line corresponds to the unimodal symmetric histogram. Now let's look at this situation. I've got a histogram. Looking at the histogram, this is clearly skewed to the right. And if you'll notice, if I drew a straight line here, it would not look like this data. I've got some curving here, and then it's sort of flattening out. So this is the kind of normal probability plot that we would say, no, we can't use a normal model because it doesn't fit that normal probability plot. So of course, in order to make it, there's two easy ways to make it, whichever you're most comfortable with. Using StatCrunch, you're going to load in your quantitative data. You're going to go to Graph and then QQ-Plot and select the data and click Compute. And I'm not going to do that for you because those instructions are super simple. And if you'll notice, this is what that would look like. I don't remember which data I used here, but if you can see, they do plot the red line for you. And then of course, the blue line, which it actually fits it pretty well. And then if you look at the histogram compared to, if you look at the histogram compared to it, you can see it does look fairly unimodal and symmetric. So that's a good thing.